Good morning, dear students. Today we are going to start with the second chapter, that is radio frequency identification technology. So, what basically an RFID technology is it's a very powerful wireless technology that is transforming how various industries operate. So basically, it enables efficient identification and data capture without having a direct visual contact. So RFID is all around us, in library books, toll plazas, access card, hospital equipment, and even in your school or college ID cards. Now we will see what exactly it is. Simply, we put like RFID uses radio waves to automatically identify and track objects, animals, or even people. So without it needed a direct contact or a line of sight like a barcode technology required. So RFID technology basically has three important sections. One is the wireless identification, where RFID tag basically transmit data via radio waves, allowing for automatic identification and data capture, and its operational gets efficient through by revolutionizing industries by its enhancing tracking, management, and automation capability. Third is like it has got no line of sight requirement, unlike barcode system needed. So RFID system can read tags without having a direct visual path, even through material also. So now what makes RFID different from other technology? So basically you can see that RFID technology introduces a very fast paradigm shift in the data capture and inventory management system. The fundamental difference enables RFID to transform your industries from retail and healthcare to logistic and manufacturing, delivering unprecedented efficiency and accuracy in the system. So we can see that the barcode basically requires line of sight, as well as it is very prone to damages, and RFID is very efficient. It reads multiple tag at the same time, as well as it does not require a line of sight approach. So now how the revolution of RFID takes place? Basically it was introduced uses in during the World War II, where the radar, basically it was used in the radar system, which was used to identify or distinguish the friendly aircraft from the enemy ones. Later on in 1970s, the technologies were adopted by civilian uses, such as in livestock tracking, automatic toll collection, as well as and basically with time, as electronics become smaller and faster, RFID system become more affordable, and it was used in widespread manner. So now what is basically the core principle of RFID technology is? So we will understand that RFID is based on the principle of electromagnetic coupling or radio wave communication. The RFID system basically consists of two important parts. One is the reader, which sometimes called as an interrogator, as well as a tag, which is attached to for identifying, which basically used to store the identification information which is being used by the system. So how it basically works? First is the reader sends out the radio waves, and this radio wave basically energize the tags, which gets activated and send back the information stored in it, such as an identification number. Now the reader receives and decodes that information within a milliseconds, and this process allows multiple tags to read at the same time, even if they are moving, or it might be hidden in some location. So basically the mechanism we will see of RFID technology is categorized under four groups. Like one is the energy transfer, then second one is the data modulation, and then third one is the signal return, and fourth one is the data capture. Now we'll see one by one each of these particular steps which completes the principle of RFID technology. First one is the energy transfer. What in this what happens, the reader basically having an antenna which emits the radio waves, and this radio waves which basically power the passive tag, or it may trigger the active tag to response. Now after receiving the energy, the tags which is having a microchip in it processes the incoming signal, and then it encode the stored data and prepare for transmission. With this whole process we call it as data modulation, where the transformation of data is being happening to be transmitted through the tags. In return, in signal return, what happens, the tag tag transmit the data back via backscatter technology for ultra high frequency, or magnetic induction process for high frequency signal. The reader then receives the data via the antenna, and decodes it and processes it for the information for further use by the host system. So now you can see that the RFID enables automatic identification and data capture in milliseconds, which allows reading multiple tags simultaneously without having a physical contact. Now, for completing this whole working principle of RFID system, the RFID system, there are few components are present in the RFID system which we need to know. Basically the RFID setup consists of 5 main components. They are one is the RFID tag, which basically is an object which has a microchip in it, which stores the data, and an antenna to send and receive the signal. So this particular arrangement is in the form of a different shape, and they are in the form like labels, cards, or hard tags. Then second component is the RFID reader, which is also called as interrogator. Now this is the system's brain, which basically sends the signal to the tag to activate them, and reads the data which is present inside the microchip of the tags. Now this reader can be fixed, or it can be handheld, or and can be powered by the USB source. Now next, RFID reader consists of RFID antenna, which basically converts the signal into radio waves, and this antenna is used to energize the tags as well as to receive the signal which are being sent by the tags. Now the range of between the tags and the reader totally depends on the antenna design, as well as the direction in which the data will be read by the reader will also decided by the design of the antenna. Now after the data have received the data will be sent to the host system, which is normally a computer system where the reader is connected for further processing of the data. Now this software or host system basically it manages the data collection, analyzes it, and store it into the database system. Now this particular software can be a ERP system or any database management system which is used for further where the data can be utilized for further process. And last one is the optional component, fifth one, that is the RFID printer, which is used to print for the labels, RFID labels or cards, which can be used at the same time. Now these are the 5 components present inside in the entire RFID system. Now next, we will see how the RFID system is being classified. You can see the RFID system are classified under 3 types. One is the passive RFID, second one is active RFID, and under that one more, that is semi-passive RFID, that is battery assisted. Now based on the power source, passive RFID has no battery. That means it is being powered by the reader signal, and the range is up to 25 centimeter. And this RFID system is utilized in inventory and retail management system. Now second one is the active RFID. Now here we need a battery. So it has got a separate battery requirement, and it is used for long range communication up to 100 meter or more. And this system is used in for tracking vehicles, containers or assets in large areas. And then third one is a semi-passive RFID, which is battery assisted. That means a small battery will be needed for internal operation, but it totally relies on the reader for communication. It does not take the support or totally dependent on the battery power source. So it is called a semi-assisted or semi-passive RFID system. Now next, RFID system is also classified based on the frequency which we are used for communication purpose. So there are four categories are available. The radio frequency band, which is categorized low frequency, which is up to 134 kilohertz. High frequency HF or NFC, which is 13.56 megahertz frequency. Ultra high frequency, which is 860 to 960 megahertz, and then microwave range, which is 2.45 gigahertz. So you can see that the range will also be dependent on the frequency which we are using. For low frequency up to 10 centimeter, up to high frequency is up to 1 meter, and ultra high frequency is up to 12 to 25 meter, and microwave is similar to ultra high frequency, that is 12 to 25 meter only. Now for pros and cons of this particular four types of radio frequency systems are like for low frequency, pros is works near to metal or liquid. It is for short range and uses only for animal tracking or basically access control in offices or for vehicle tracking purpose, vehicle access control. Next is NFC. High frequency is used having advantage of NFC compatible and secure. It is a secure system. Disadvantage is short range and uses it in ID card, library or payment system. Then ultra high frequency is used for long range and it is faster as compared to other frequency band. Next, at disadvantage is affected by environment and uses in supply chain and retail system. Microwave is very fast and limited use. It is only used for specialized tracking only. So these are the different types of RFID system which is being categorized by power source as well as by the frequency. Now next is we will see some advantage and limitation of this RFID system. First one, we'll see the advantages. RFID offers several advantages. Like first one is the efficiency. It reads multiple tags at once. No line of sight needed. Accuracy is very high, like it provides real-time data capture, reduces human errors. Second is durability. Works in harsh condition like dirt, moisture, etc. It provides security, like we can have an encryption in the while sending the data or receiving the data, as well as it requires we can introduce authentication system also. And next is the integration, very easy and works well with IoT system and analytics system. Now coming up to the limitation, like every technology has its own some limitation. Similarly, RFID has its own challenges. First one is the cost, like readers and tags can be expensive initially. Later on, like based on the mass production, the cost can be reduced. Then there is the interference from the metal or liquid may reduce the accuracy level. Then privacy issues are there. Unauthorized tracking is possible, though the the system is regulated by ISO standard. Then variable range depends on the environment and power source. It depends on the power source. The range can be may get affected, and there is the environment effect also where the range of communication may get affected. So these are the challenges in RFID system. And then next is the application. Now the RFID depend as the technology is evolving and has got a very wide range of applications. For example, like supply chain and logistic. where real-time goods tracking and is possible, as well as it reduces the loss, and it's a very precautionary measures for avoiding the loss. The next retail system, which basically automated the checkout and inventory management. Then healthcare for patient tracking, equipment management. Then manufacturing, where tool tracking and production control can be done. Access control for entry of system for offices and vehicles, as well as in agriculture, animal and livestock manufacturing. There are other applications like in library books, toll collection, and even in sports event timing. So these are the major application of RFID technology. In the next coming session, we will study about the in details the components of RFID system, how it basically works, and the protocols which are being used in RFID system. So this is for all. Thank you very much.